Hello, I am Pankaj Sharma from Brainleague Learning. In this lesson, we will build a clear, intuitive understanding of Kirchhoff's laws, Kirchhoff's current law, and Kirchhoff's voltage law. We will define each law, see why it makes sense, and work through simple examples. Kirchhoff's current law, or KCL, says, at any node, the sum of currents flowing into the node equals the sum of currents flowing out. Why? Because electric charge does not pile up at the node. Whatever goes in must come out. In equation form, take currents into the node as positive and currents out as negative. Then the sum is zero. Let's do a simple example. Two currents in 2 amps and 3 amps and one current out. What is the outgoing current? Kirchhoff's voltage law, or KVL, says, in any closed loop, the algebraic sum of voltage rises and drops is zero. This is energy conservation around the loop. What the source gives, the elements in the loop must use. In symbols, sum of voltage changes equals zero. Let's draw a simple loop with one battery and 2 resistors in series and check KVL. Let's solve a quick KCL problem step by step. 2 currents go into a node. I sub 1 equals 3 amps. I sub 2 equals 1.5 amps. 1 current leaves. I sub out. Write KCL. I sub 1 plus I sub 2 equals I sub out. Substitute and compute. 3 plus 1.5 equals 4.5 amps out. Now, a quick KVL example. Suppose the battery is 12 volts and 2 series resistors drop 5 volts and 4 volts respectively. Write KVL around the loop, plus V battery, minus V1, minus V2, minus V3 equals 0. Solve for the missing drop V3. It must be 12 minus 5 minus 4, which is 3 volts. How do you use these laws on real circuits? Step 1. Identify all nodes and loops. Step 2. Write one KCL equation for each independent node, excluding ground. Step 3. Write one KVL equation for each independent loop. Step 4. Solve the resulting system for unknown currents and voltages. Remember, KCL is conservation of charge. KVL is conservation of energy. Together, they unlock almost any circuit problem.